So I have a website. It's not super nice, but it's super fast. That's servando.text.no. A bit about me, yeah. I'm from Spain, from the northwest, almost close to Portugal. I studied electronic first, sound afterwards, and then I moved to Madrid, where life circumstances I had to switch from audio, that has been always my passion, to visuals. And this was interesting because I saw the connection, like with audio, is working in a similar way. It kind of added to me. And it was actually in Madrid. There's a place called Media Lab, and usually they do courses, free courses in free technologies like open source. For instance, the first Arduino workshop in the world happened there, and I was there. You know, Quartielles, Massimo Banzi, the creators of Arduino, when it still was a serial port. There was an Arduino with serial before the one with USB. And then we went together to Ars Electronica in Linz. Very important. It's happening right now, right? So it's an important event for those into audio, tech, visuals, contemporary art, experimental electronics. And there was one person there, Hans Steiner, that is one of the maintainers of Puredata. And I heard them giving a panel about Puredata, why it's cool, and I got totally convinced. I realized, this is the way to go. I can show you quickly, Javier, a portfolio. So some things I have done is, for instance, audiovisual synthesizer, putting together my previous knowledge, my background in electronics and sound, but also what I learned about visuals. I'm gonna go quickly through these things. I don't want to bore you with. You can always check if you're. Does any of you know Buchla synthesizers? Very, very inspiring. So in Stockholm, in Sweden, is one of the places where I lived. I lived there 4 years. Is where I got to work with Teenage Engineering and Polestar. We did an installation in Milan with electric cars and synthesizers and lights and sound and controlling all together. And there is where I got introduced to Buchla synthesizers that are, since the 70s. There was like a very inspiring place to go. This is called EMS, Electronic Music Studios. So this installation can be seen in Stockholm, or there's another one in a museum in the United Kingdom, in Newcastle. Yeah, so live.org, something like that. It's like a technology museum. There's kids around. That's why we made a version with military-grade components, so no one can destroy the machine. Video mapping, things that I have done also with Puredata, because there is a graphical library. Well, there's actually several graphical libraries, but there was one called GEM. Once you learn to connect things, connect them with the controller, you make a sequencer, then, if you make a visual patch, the connection between the things is immediate. This is the Polestar and Teenage Engineering installation, and I'm running it a little bit. You will see a bit the cars.
Milan. The name is synonymous with design, not least because of Milan Design Week. This event
also, and each of the 4 open cells, speakers and lights are linked with one of the tracks.
with design forming the bedrock of Polestar's identity, along with a willingness to look outside their own industry. The fun of a...
Essentially, what they don't explain in this video, it is very nice and so on, but is that you have the triggers and you have the electric cars, slot car racing. In Spain, we call them scalestric. So you control the cars usually. In this case, what I did with Puredata is put all together. So when you use the trigger, you move the car, but you also control the lights. Like there's 4 lights, 4 cars, 4 speakers, and 4 synthesizers. Like in every corner of the table, maybe we see at some point, there was 4 synthesizers that were actually doing playing the music.
Polestar aimed to embody two things with these installations.
We could actually fake it, but
the
no,
fun of electric mobility.
We didn't. We were actually controlling via MIDI. The music was split in 4 tracks, like drums, bass, chords, and melody. And whenever you were using a trigger, you were controlling the car, the light, and maybe if you were controlling the red car, that is drums, maybe there's some hi-hats that come in and stuff. My biggest work is the RBMA20 or the Red Bull sequencer machine. We could also play a little bit. Oh, we can also do like this. That's why I usually... yeah, and this was actually through Johannes that might come later. So Johannes runs a company called Data Machines, and we knew each other for doing audio. Why does no? Oh yeah. What this machine is at the end is a giant MIDI controller, kind of, but custom made. So there's 3 panels. The one in the left is like a drum sequencer controller. And here in this box, I don't know, we see at some point, there is actual drum machines. So in these sequencer lanes, you do a sequence, you put your bass drum here, here, here. But also you can select, I want the bass drum from the 808 or the 909 or the Vermona. So independently you can choose which drum machine. Also there was like an Easter egg that I don't know if someone found that you could half of the machine could run in 7 steps. So 7 against 16, so then it does like some funky polyrhythms. But you had to do different buttons at the same time. I know. The middle panel is like controls looper, clips and samplers. And the third panel is a Euro rack sequencer that has 3 lanes. And every lane it has 3 parameters, like the pitch, the velocity, and an extra parameter that could be cut off or something like that. But the thing with the funny story about the Red Bull machine is that Johannes approached me because Johannes, the Data Machines, was doing the hardware, like the PCBs for this Red Bull sequencer. So they thought, and first they contacted Korg, that actually said that it was impossible. Like they had 1 year to do this machine, and they said, no, it's impossible. And when there was kind of 2 or 3 weeks left for the deadline, pure data power. So Johannes approached me and said, hey, can you do a sequencer in Pure Data? And I was like, yeah, of course. I mean, I've been doing it. I was playing around and doing also in the computer my own library. This thing that looks a bit like slightly inspired by Ableton Live, as you can see. It was my own library of things, like sequencers, samplers, FM, synthesis, VA, the things we all do to practice. So it was actually done. This is the emulation. So I haven't been asked to do this, but I did. So I did a PD patch that resembles the machine. So I could, without having the machine, test how it works and put the triggers myself here. And you can see here, not just here, actually. You can see it in my GitHub. This first part of the machine, I had it already. And the funny part is that this is actually the first, not the first patch, but the first big patch I made when I moved in Berlin in 2008. My first winter here, it was super cold, and it's like, I don't want to go out. So it's like, I'm gonna clone the sequencer of Fruity Loops. I like this trigger sequencer. Very simple, very graphical. It's almost like a game. So that's what I did. So when they asked me to do this, adapting this patch to their needs, it took me like maybe 2 days. So the first panel of the Red Bull machine was done in 2 days. The others took a bit longer, but still it was okay. So moral of the story is like, if you're fast, try to slow down. You could go to my GitHub, and in the PD workshop here, there's some materials, and here is the sequencer. So here is the first panel. It's exactly that. And here you can also select 4, 8, 16, or anything in between. And I even included the Ableton link. So when I do workshops and the students are starting to do sounds, they are in sync, which is cooler. It's not intentional that actually all the works featured in my portfolio are made with Puredata. Like, all these things. Sometimes I use also hardware like Arduino, or there's another board called Axolotl, which I love. And at the same time, Axolotl was very inspired by Puredata. Intelligent speakers, they're hanging, they have a microphone, they analyze the audio, and then they resynthesize the soundscape of the room, and later at random times they spit a synthesized version of whatever happened in the room. So, yeah. Visual, interactive performance. Maybe I play some seconds of this. This was also in, in Norway, in Bergen. There is a festival called Pixel. It's a festival, like electronic festival, electronic music and experimental. And the condition is that it has to be done with open source or open hardware. So I've been there many years. And this patch, this is Puredata and Gem. So this camera, this is no Kinect or anything. It's just a webcam that analyzes the movement and draws my movements. So if I'm staying static in front of the camera, I disappear. But when I move, it's like it makes a trail of the movement. And the sound is like an early version of granular synthesis that was also done in PD. Long ago. You can see a bit, right? That's the trail. Then again, this is in Bergen for working for the same festival. It's quite a large, it's in a tunnel coming from the airport to Bergen, Skjøl tunnel, something like that. It's like a 60-meter long display, and it runs a Puredata patch that chases the trains. It's called like a Boyd's algorithm. So it's like birds chasing a prey. So it's balls of light chasing the trains, and there is like some infrared sensors in the tracks. So that's how we know that the train is passing by and how the balls are moving. The video is little bit shabby, so if you want to see, is there. This turntable, basically, it plays modified records, which I painted in white, and I made holes on it. So what is written in these holes is binary code. So when you put the disk in the system, it gets recognized, and the system knows, okay, this is the disk hardware, and then it will play pictures, and when you scroll it with your hand, you can navigate through the images. and I choose to put images that relate. Put it control. Now there. Here we go. Yeah. So usually you put the needle in a record, you play the music, and it might make you dance. This is the opposite. You put the needle in the record, you dance, then you get music. So I had to use a webcam, Arduino in this case.
Una que te muevas y te pilla, ¿eh?
And we all stop and you see how it reacts immediately. So yeah, there's other things that can be done with Puredata. I like to inspire people to do weird things. Yeah, this was actually shown in this is ICC, this super giant building.
Stirren. It's a recycled Frankenstein.
So
Converted
actually another Puredata guy, Joao, that is not here today. Yeah, but he gifted me a computer. It's like, I'm so fed up with this computer, it doesn't work, whatever.
Interactive installation.
So he gave me for free the computer, but he, of course, removed the hard disk because he had the information. But I knew that there are Linux distributions that can run out of a USB stick. It was called Puredata. So not just that, it was a Linux distro that was running in a USB stick and had Puredata on it. It was called Puredata. So it was Dynabolics with Puredata. And I could, run that installation, put a webcam, speakers, and I put an accelerometer. So part of the
better illuminated.
Part of the fun in this installation is that you were allowed to actually grab the monitor and shake it, and it was kind of glitching when you did that because the accelerometer was detecting the interaction with it. Yeah, here we can see that's a bit you could see more. Here to mention, for a while, now I would have to kind of dive back in the time machine to see. There was a place called NK in Treptow or in Trepköln, and all the people in this place, they were into experimental music and technology. So Farah, that was running the space, told me, hey, would you like to organize a Puredata user meeting? Because they were doing already Super Collider meetings. And it's like, yeah, sure. And then together with Joao, we started the Puredata user meeting. And then later, Malte Steiner, a guy from Hamburg, that together we made actually a band called Rechtlichtverstärker. And he put the name, obviously. And before Ableton Link, I came up with a way, nothing super original, of syncing the computers via network. So essentially, and probably you could see, if you download this patch here, you're going to see somewhere like a OSC receiving. So essentially, I was sending the metronome over a network. Mostly works, it can work in wireless if you're just two, but better, we realized that if we use cable, then we could sync up to 1,000 beats per minute without skipping stuff. So it was really working, and we performed in a Pixel Festival, Linux Audio Conference, and PD Conference. It must be a picture or something, yeah. So that's me and Malte using Linux. And I'm still do, yeah. Yeah, then at some point, it's worth mention maybe, I mean, this is a bit old stuff, but in one of these conferences where we were to perform, I think it was in Graz, someone was bringing one of the first Raspberry Pis, and they made a distribution, Satellite Karma, for audio. And their idea is that you get a Raspberry that is very cheap, 20 euros, 30 euros. You connect some sensors, you put the sound card, or even you use the integrated sound. You download that distribution. They included Puredata with it. So you could do like an embedded instrument. With that, then I made a looper in Puredata, of course, and you can see that this is the Raspberry Pi 1. I play a little bit. This is my most viewed video, by the way, like it has 60,000 views. And so essentially, it was like 4 audio loopers with different length each. It could be slate, but you could also actually quantize. Could be like in bars. So 1 bar or half a bar, quarter of a bar, or 2 bars, 3, 4. And it had send effects and also insert effects for the input. So if I was connecting a guitar or something like that, I could apply, like a filter, saturation before recording. This was long ago, and 14 years ago. When is this article from? 2013. So it rained a little bit since. I wrote the article actually, and Peter Kern from Create Digital Music, he mostly pasted what I wrote. He added some other stuff. So I hope you see at least how everything connects. Doing something for fun and suddenly becomes serious, well-paid work. I've been doing Puredata workshops since long time. Some of them are quite well documented. I like to put this one because in Zurich there is like a Mechar Lab or SJMK. They do cool things with electronics and sound, open source, open hardware. They love hardware. So the idea is that what if let's do something physical with Puredata. Of course, you can also do it in a laptop and then hide the laptop in a plinth, like I did for that installation with the binary turntables in Transmediale. But now we are in different times. So now microcontrollers, even ESP32, that is like a $5 microcontroller, can run Puredata. So these are more reasons to still use Puredata. This is the DAISY that is more powerful, and there's like a Eurorack module that runs Puredata. Well, not just one, there's like a bunch. There are at least 5 Eurorack modules that run Puredata. And since it's a wiki, we all edited, we pasted, so we can see how the workshop went. It was full, even though we announced it like 1 week prior, but people was quite interested. And here there's there's a smaller version of the DAISY. This is the seed, and the other is the patch. So you can make guitar pedals with it, and even like a DIY Eurorack module. And Mark, the guy that runs the Mechar Lab, this is like a laser cut and then CNC. So he made the panel to look like a PD patch. And the knob is all printed at once. And some 3D printers now can print in different colors without changing the filament. And he made it look like some people will recognize, like the Puredata knobs. And the cool thing in this page is that there is tons of links. So as I mentioned, Puredata can run as a VST thanks to plug data, or also there is a new thing called PD VST from Miller itself, which is cooler because it allows for running also externals. So there is the so-called vanilla, the very pure data. And then when you add your own modules, either C or C++ or other languages, then these are externals. Flows Manuals. Yeah, I contributed to this manual. Flows Manuals is a pure data manual online. But it's a bit old now because back then there was like a version that had all the libraries. It was called PD Extended. It was really cool because it was all the community contributions were there, bundled. The bad thing is that now that people stopped maintaining it, it's like, oh, I downloaded the patch and it doesn't work. So you got to look for, okay, which objects are a bit like it happens with code. It's like, this doesn't work. Why doesn't work? Read the errors. This object doesn't exist. So what is this? It's from this library. So you got to download that updated external and then declare it. Same way that you do with code. But Miller Phuket, so he's still there. He's in IRCAM, back where everything started, actually in the 80s. So Miller started Max MSP in the 80s, and it was commercially released in 1990. The issue is that at some point, and I pasted this here because I think it's important for those that care, where do the things come from? So he wrote, this is the history of Max and PD. So he had the idea already in MIT. He called Max in honor to Max Matthews, and MSP is his initials. When you go msp.ucsd.edu, that's Miller Phuket page. And here you could see that he's a bit pissed off because his IP accidentally, their way of arranging bananas, whatever. He's doing examples with, what if you go to a supermarket and change the order of the bananas to make a point about intellectual property. And here is when at some point it says that, getting back to my own story, I left IRCAM and when they will not permit my own further work on Max to be disseminated, I gave up and started a new project, PD. One meaning of PD was public domain. There's a joke because PD in French, for those who know French, it's like a bad word. So it's like is my software, do what I want with it, So, not against Max, but as he usually says, whenever he does a talk and he mentions, well, I wrote also Max, Max is cool and you can buy it, and usually he continues, and PD is also cool and you can just have it, and people is like clapping, like, yeah. His main goal, the reason why PD looks so minimalistic and square and black and white is because Miller doesn't want to use dependencies. Pure data is written in C. And his goal, whenever people ask, okay, well, what's your thing? So he's still working on it. His goal is that you make a PD patch today. And in 30 years, you're still going to be able to open it. No matter what the operating system of the future is or the type of processor. I mean, currently it runs in Linux, MacOS, Windows, Irix, Raspberry Pi, ESP32, Raspberry Pico. So that's reasons, to use PD. I could also open it. I can show video here. In that video, I'm using the accelerometers of the phone, sending via OSC to a vanilla patch that can be compiled as a Unity plugin. So that's the thing. Or, last thing quickly, before... So this is oscilloscope. I don't know if you can see it from there. Is this old electronic laboratory equipment that has two inputs, two AC coupled inputs. So using Puredata, you can generate audio that actually draws shapes. So that's what I did. And if I had to do it from scratch in C++, it would take me a while. But yeah, I'm so used to Puredata that even crazy things like this for me is like just playing around. Last thing before wrapping up and just making some cool noises, I thought, if I just had 5 minutes to teach a PD workshop, what that would be. Because before, when I was in Madrid, and I learned about Puredata, and I saw how cool it is, and I had clear that this is the way to go. But always, in Spain, it's warm outside, people drink beer in the streets, it's very attractive to just go out and spend time with the... When I came here, and was the first winter, as I already told, is when I became a PD expert in 1 week. And I realized about something important. You install PD, I guess you can figure out from where, or I could tell again. This is like a terminal. So when you do something, you put a print here. Now you put a number, you connect the number. Boop. So this is how you do a hello world, if you write hello world in a message. I realized that there are 3 basic things that once you know these things, there's no excuse. Like, how many people here never heard about PD or didn't knew anything about PD? Anyone? Good, good. Today is the day. I realized the things to know is when I click in an object and I can move the numbers, or if there's a button and I can bang it and it does like that, this is the control mode, like the performance mode. But if now I go here, I can do it through this, or with Command E or Control E, depends on your system. Command E. So now I can move the things. So this is the edit mode. In edit mode is where you put number. How was it? The change. Slider that also sends numbers compatible with MIDI. Something else. This is the edit mode. Is how you work, and you can put a comment. Hello. You can put a message. Hello world. And now I connected, you go always from outlets from the down part. This is the resemblance with code and with text that you start from the top and go to the bottom. So you always connect from the outlet, that is this one, to the inlet. And now you see this icon that looks like this indicates that I'm in edit mode. Now when I click Command E, now I'm in control mode. So now it's when I can click and interact with the objects. So, right? So this is one of the things to know. Edit mode, control mode. The other thing is when you do control click in any part of the canvas, there's a help here, and there's a reference of the objects. So you start reading, and it's like, this gives you an idea, like, arrays, oh, I can handle files, or here there is, math with numbers, also with signals. There's MIDI. Not a lot. I mean, it's doable. You can take a quick overlook here, and the top secret is here. You go to Help, Browser. Hello. Here. Puredata. Audio examples, and there is these beautiful, amazing examples that you can click, and they work. They are functional code. So it's going out in my. So I do like this. audio, and I said TX6. So I can interact with the patch like this. And yeah, you can also go inside, look at how the things are made. And whenever you don't know what something does, like what is R, pole, tilde, you go to help and you have help about of the objects. You don't have this in C, even though it was made a million years ago. So I think there's no excuses. Like once you know edit mode, control mode, where the help is, no excuses anymore. And yeah, I think I could, as I thought, I could talk about this for hours and hours and hours. But I think this is kind of a nice way to wrap it up. Oh yeah, right. Questions.
Hey, I used to work a little bit with Max, and when you showed the Red Bull sequencer, it had like a million cables, and like the whole thing looked quite scary.
Yeah.
And I have two questions about it. First of all, how was the stability? Was it crashing a lot, or was it like perfectly smooth?
It is running since 2019. And if you want to play with it, because people can play with it, it's in a museum in Amsterdam called Our House Museum. It's a museum dedicated to electronic music culture. Our House Museum. But it's a good question because it's actually bad code. But yeah, it's been running since, and that patch. Usually I shouldn't share, there's two reasons for not sharing code. One is out of greed, and the second is out of shame. But still I decided to share because this is ugly and wrong. Doing sequencers with select 1, 2, 3, 4 is inefficient and dumb, but as I thought, it was my first. Now if you go here to my GitHub and you click PD Workshop, you are going to see that one, but then you're going to see another one here. And when you open it, it's just 3 objects. I use a table, and then, tab read, tab write, metronome, whatever. So you can do a sequencer with super minimalistic, super simple. And one of the characteristics of PD is stability. It's tremendously stable.
I have a question also for the Red Bull sequencer. How do you interact with or interface with the hardware and get the signals from all of the switches back into a computer, or what are the different interfaces that you use for all the projects?
Mm-hmm. Yeah, I wish Johannes was here because he could tell you a bit more. He is essentially 3 panels with a bunch of buttons, and was at least 3 Teensies. Teensy, this small microcontroller, at least 3, if not 5. I think maybe 5 Teensies. And Johannes made a custom PCB hardware where you put the Teensy on it, and every PCB has Ethernet out. So, and then someone else, Sven Braun, from Zmors, another German audio tech guy, made a special firmware for the Teensies that was getting all the inputs from the multiplexers, because of course there was a bunch of multiplexers in the PCBs. So there was multiplexers that were getting the inputs from the switches, and then the Teensy code was generating MIDI, and we were using full-on, like a lot of channels, notes, and also CCs, and even from 0, because there was so many stuff. I think it was more than 500 buttons. Now I can't recall, but the cool thing is when you do the things in PD, copy-paste works actually quite good. Like if you do one step, you can do another step, and then when you have one bar, and you do it right, and you plan, when okay, I'm going to need more, So you do it in a way in which once it's done, you just copy, paste, copy, paste, copy, paste. This works really good in Puredata. And lately, Miller added a magic object called clone, in which you, inside of that object, you can have multiple copies of one code. So one of the things I use clone for is to do multi-channel installations. So you can give me any arbitrary number of speakers, like 100 speakers, and I could do right now, quickly, in 10 minutes, a multi-channel installation for 100 speakers. Because you can replace, you use variables, so you do clone, and then you do like a oscillator. You tell, okay, 100, and then to send to DAC $1, which is going to be replaced by the number of the instance, so you can have an oscillator per speaker. And then you can determine like a center pitch, like they are all 60 hertz, but then you can determine also like a variation from the center pitch. So for doing granular or swarm is ideal.
Okay, I think I'll do the outro now. Anyway, let's put our hand together again and thanks, Servando. It was a really nice talk.
Thank you.